name is Shikha Jain, and today's topic is recursion in C. So, first of all, we'll see what is recursion. Recursion is a process in which a function calls itself directly or indirectly. Means when function calls itself, then we say it is the process of recursion. Now I'll take one example and see how recursion works. So suppose there is a main function which is calling a function named A. Right? Now in the definition of A function, again we are calling function A. Here we can see the function A is calling again itself. Means A function is calling A, then we can see this is the process of recursion. Now if I insert a print statement here and we are printing, suppose this is recursion. Now what will be the output of this code? If we see the output of this code is this code will print this is recursion many times. You can see here first the main function is calling A function, right? Now in the definition of in this A function, it is again calling A function, right? First it will print this is recursion. Now it is calling again a function named A. The cursor, the control will go to the definition of A and again it will print this is recursion. So then the output of this code will be this is recursion many times. And at one point of time, it will stop printing recursion and the system may crash due to stack overflow. Due to stack overflow, system may crash and it will stop printing this is recursion again, right? So what is the stack overflow? We will see the concept of stack later in this slide. So we see this is the process of recursion, but there is a problem. So to overcome this problem, the recursion process should stop at one point of time, right? Otherwise, it will print many times same output. So to think base condition or terminating condition is must. We must think the stop condition for this recursion. Means at one point of time, the recursion should stop. So there is two things are required for the procedure of recursion. First, we should specify some base or terminating conditions to stop the recursion. And the other one is the recursive call. Means one problem should be divided into some sub problems. Right? So this is the process of recursion. Now we see the basic structure of recursion. Suppose there is a function named recursion, right? And here it is if condition and one is else condition. So in this if condition, we must specify base case or we say base condition, and this else part we must specify recursive function or recursive procedure. So this is the basic structure of the recursion. Now next we will see the in detail process of these two statements. Now I take an example of factorial, finding the factorial of a number. Then we will see these two statements, like how we divide this problem into these smaller subproblems and what should be the base case of a factorial, right? If we say what is the factorial of 5, it is 5 into 4 into 3 into 2 into 1, right? Now, if I write like factorial 5, factorial 1, what is the factorial of 1? It is 1, right? If I write factorial of 2, it is 2 into factorial 1, 2 into 1, and how it will write 2 into factorial 1, right? Now if I write factorial 3, we can write it like 3 into 2 into 1, right? 2 into 1 can be written as factorial 2. So the statement would be factorial 2, right? Now if I write factorial 4, it is 4 into 3 into 2 into 1. And what will we write for 3 into 2 into 1? It is factorial 3. So we can write it 4 into factorial 3. Similar case for factorial 5. It is 5 into 4 into 3 into 2 into 1. And this 4 into 3 into 1 can be written as 5 into factorial 4. Right? So now what should be the stop condition for this factorial? If we see, if I stop here like factorial 3, can we stop over here? No, because this factorial 3 is dependent on factorial 2. Now we see factorial 2 can be the stop condition. No, because factorial 2 is also dependent on factorial 1. So if we see here factorial 1, this factorial 1 returns 1. So this can be the stop condition. That means when the value of n will become 1, it should return 1. It is not dependent on any further factorial, right? So what should be the stop condition? If number equals to 1, then what it is returned? It returns 1. This is the stop condition, right? And what is the recursive case? We see here factorial 5. Factorial 5 is further divided into 5 into factorial 4, means it is dependent on the previous statement, that is factorial 4. Now we see factorial 4, it is dependent on factorial 3, and factorial 3 is dependent on factorial 2. So we can write it like n into factorial n minus 1. In its present state, it's dependent on the previous state, right? So we can write it n into factorial n minus 1. This is the recursive case. And this is the base case. Now if I write it in the basic structure that we have seen in the last slide, the complete code for this recursion is int fact int n. This is the argument. And what is the base case? If n equal 1, then it returns 1, means factorial of 1 is 1. Else it returns n into factorial n minus 1. This is the recursive case, right? So this is how we think the recursive case and the base case or stop conditions. When n equal 1, here the recursion will stop. Now we will see the complete program for finding the factorial. So here's the code. This is the driver function, main function. Here we are calling the factorial n. Now if n equal 1, then it returns 1, else it returns n into factorial n minus 1. We compile this code. Suppose I want to find the factorial of 5, the output will be 120. So this is the complete code for finding the factorial. Thank you.